In Lesson 4.6, we will be learning about congruence in right triangles. So let's take a moment here to look at a right triangle. In a right triangle, the side opposite the right angle is called the hypotenuse. It is the longest side in a right triangle, and the other two sides are called legs. Here's the right angle, and it's pointing at our hypotenuse. This gives us Theorem 4.6, the hypotenuse leg theorem, which states that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. So here's what this looks like. If triangle PQR and triangle XYZ are right triangles, and segment PR is congruent to segment XZ, and segment PQ is congruent to segment XY, then triangle PQR is congruent to triangle XYZ. So let's take a minute and try to prove this. Given that triangle PQR and triangle XYZ are right triangles with right angles Q and Y, actually segment PR is congruent to segment XZ, and now segment PQ is congruent to segment XY, we need to prove that these two triangles are congruent. So the first thing that we need to do is to this triangle over here, we're going to draw ray ZY and mark a point S so that the distance from Y to S equals the distance from Q to R. And that looks like this. So on triangle XYZ, we've drawn ray ZY. We've extended it out. And we've marked a point S so that the distance from Y to S equals the distance from Q to R. This makes triangle PQR congruent to triangle XYS by side angle side. And since corresponding parts of congruent triangles are also congruent, segment PR is congruent to segment XS. And since it's given that segment PR is congruent to segment XZ, then segment XS is congruent to segment XZ by the transitive property of congruence. And now by the isosceles triangle theorem, we can say that angle S is congruent to angle Z, so that we have triangle XYS congruent to triangle XYZ by angle, angle, side. And finally, we can say that triangle PQR is congruent to triangle XYZ by the transitive property of congruence. Before we move to the first problem here, we're going to talk about conditions for using the hypotenuse leg theorem. In order to use this theorem, the triangles must meet these three conditions. There must be two right triangles, the triangles must have congruent hypotenuses, and there must be one pair of congruent legs. So let's work the first problem. Okay, problem 1, we're going to use the hypotenuse leg theorem. And this is another instance where my artistic ability is lacking, so I just took this diagram from the book. It's supposed to resemble a basketball backboard and hoop. So right here you'd have the basketball backboard, and then you'd have the hoop right here with the net. So we're going to take that stuff off there here in a second, and we're going to get to work. Okay, so the problem says that a basketball backboard brackets form the shape in the diagram, right over here. And that angle ADC and angle BDC are right angles, and that segment AC and segment BC are congruent. And as this are triangles ADC and triangle BDC congruent, and to explain. So the first thing that we're going to do is we are going to pull out the given information that angle ADC and angle BDC are right angles. Therefore, triangle ADC and triangle BDC are both right triangles. The hypotenuses of the two right triangles are segment AC and segment BC. And we're also given that those two segments are congruent. Now, since segment DC is a common leg of triangles ADC and BDC, then segment DC is congruent to itself. segment DC by the reflexive property of congruence. So the answer to problem 1 is yes. Triangle ADC is congruent to triangle BDC by the hypotenuse leg theorem.